Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the design approach for the flexible pavements. Now, the different methods they are being used for the design of the flexible pavements, but two methods they are being most commonly used. One such method is the GI method, that is the group index method, and second is the CBR method, that is the California bearing ratio method. Now, the group index method is an arbitrary index, and this index it is given to the type of soil. The percentage of the liquid limit, plasticity index, and fines are the important factors because in the design of the flexible pavements, it is based on these factors itself. The GI method, that is the group index method, it basically gives the information or it uses the percentage of the liquid limit, the plasticity index, and the fines only. And the GI method, it does not take into account the characteristics of the pavement material. So the Indian Road Congress, it has recommended the California bearing ratio method for the design of the flexible pavements. So the method which has been followed by the Indian Road Congress, that is the California bearing ratio method. So in the year 1928, the California Division of Highways in the United States of America, they developed the CBR method for the pavement design, and the majority of the design curves they were developed later. They basically were based on the original curves proposed by O.J. Porter. The CBR tests were carried out by the California State Highway Department on the existing pavement layers, including the subgrade, the subbase, and the base course. Based on the excessive CBR test data collected on the pavement which behaved satisfactorily and those which failed, an empirical design chart was developed correlating the CBR value and the pavement thickness. So this became the basis of this chart. Design chart is that a material which with a given CBR required a certain thickness of the pavement layer cover, and a higher load needs a thicker pavement layer to protect the subgrade. So that means if there is an increase into the load onto the pavement, the design load, so in that case there was a requirement to increase the thickness of the pavement simultaneously. The CBR test it is basically performed on a sample of the subgrade soil in a standard loading device, and this device it measures the load required to cause a penetration of the plunger of 2.5 mm. So the cross-sectional area of the plunger it is 1960 mm. Rate of the penetration, the sample by the plunger is 1.25 mm per minute, and penetration to the sample by the plunger with this rate it is done up to the required penetration of 2.5 mm. Then the pressure at the penetration of 2.5 mm it is calculated, and it is expressed as a percentage of the unit standard pressure, and this percentage of the unit standard pressure, this is called as the California bearing ratio. The test is repeated for the penetration of 5 mm, and then the CBR is found out. The higher value of the CBR is preferably considered, and the value at 2.5 mm penetration it is generally higher. The unit standards loads at 2.5 mm penetration is 70 kg per centimeter or 7 newtons per mm, and the unit standard load at 5 mm is 105 kg per centimeter or 10.5 newtons per mm. So in the Indian Road Congress, it has adopted the CBR design chart, which is shown in the figure in the next slide. And there are 7 curves from A to G for the different volumes of traffic to be carried by the pavement which is shown in the CBR design chart. So basically a design chart is being formed depending upon the total amount of traffic which flows on the pavement, and the respective curve from A to G it is being formed. The traffic is taken in units of heavy vehicles per day in both the direction, and any vehicle with a laden weight of 3 tons or more it is termed as a heavy vehicle. Now if the CBR value of the material of the component layers of the pavement it is different, then component layers can be suitably divided with the help of the same curve which is shown in the figure. So splitting up the component layers of the pavement due to the materials with a different value of the CBR, it is a serious disadvantage of this method, and hence the total thickness of the pavement above the subgrade it remains the same even though the quality of the material used it is good. So if you observe the figure or the graph it basically denotes the CBR value in percentage on the x-axis. On the y-axis there is the depth of the construction of the pavement in mm, whereas A to G are the various curves denoting the traffic. If you see here, we have the traffic classification of the different curves of the traffic with respect to the number of vehicles per day exceeding 30 kilonewton laden weights. For the graph A, it is within the range of 0 to 15 vehicles. For B, 15 to 45, C, 45 to 150, and D, 150 to 450. For the graph E, it is 450 to 1500 vehicles, F, 1500 to 4500, and for the graph G, the value is above 4500 vehicles per day, which are actually exceeding the 30 kilonewton laden weight. So the advantages of this method is that the test it can be performed by the personnel with relatively little experience and training. So it is a relatively easy test to be performed. The test it is correlated to the service behavior and construction methods and has been successfully used for number of years. So that means the data which is being collected for the several past years, it is being correlated, and the behavior of the pavement to the given amount of units of traffic is being tested. The CBR method it adapts more quickly to the airfield pavement design for immediate use than any other method. So it can be readily implemented on any sort of a pavement, and one can test the soil with simple portable equipment. So in situ testings, that means in the laboratory testings, are easy to be performed. Hence this test it has been preferred, and one can run tests in either the field or in the laboratory for the design, construction control, or evaluation of the existing construction. That means this in situ or laboratory test for the design, construction control, or evaluation of the existing construction, that means for the design, that is the pre-construction, then during the construction, that is the construction control, and at the same time the evaluation of the existing construction, that means the quality check of the pavement, it can be done by the means of the CBR test. The test is primarily intended for the subgrades, but it is applicable to the wide range of the different materials as well. So the CBR test it actually can give us the total information regarding the different materials which will be used in the different layers, whether they are recommended to be used or not. Then testing it can be done on the samples representative of the future water conditions. So this is regarding the advantages of the CBR test. Next we will see the limitations or the disadvantages of the CBR test. So the laboratory as a field compaction methods, they are not identical. However, the comparative tests indicate that the reasonable correlation of the results they can be obtained from the field compact materials and samples compacted under the similar conditions in the laboratory. As in this test, the plunger is allowed to be penetrated into the compacted soil. So these conditions, they will not be exactly identical as on the site. So this forms the limitation of this particular test. Next, because added strength to this highly stabilized surface such as the asphaltic concrete, it is neglected, the assumption of a completely saturated subgrade condition sometimes results in a too conservative factor of safety. And lastly, because many of the procedures are of an arbitrary nature, you must run the test to exact standards in order for the design tables they to be valid. So here we end with this particular test, that is the CBR value test on the pavements. So with this we shall stop. Thank you.